2/3 of our world is covered in water. Yet we know more about the surfaces of Venus and Mars than we do about the deepest parts of our oceans here on Earth.
Oceans are especially difficult to explore.
I mean, the ocean is just too big, it's too deep, it's too dangerous, it's too dark, that it's not really well suited for human exploration.
So really to see what's at the bottom of the ocean, you have to send a robot down there and see what's there. That's the only way.
For years, our best tools for exploring the oceans have been autonomous robots. But they're limited in what they can do.
The marine robot field is lagging, maybe a decade behind the state of the art in these other terrestrial or drone robotics, just because of the challenges of working in the ocean.
Conventional marine robots follow pre-programmed tracks. A scientist tells the robot where to go and what to do.
But if you have a pre-planned trajectory and the robot's unable to adapt, you'll just pass that thing by and then come back later, and then to the scientist's dismay, you'll have seen one or two camera frames of this incredibly interesting thing, and it's gone.
In 2015, Yogesh Girdhar joined a team from the Woods Hole Oceanographic Institution on an expedition to an underwater mountain off the coast of Panama.
We're still exploring it using the standard approach, which is we went to the mountain and then the scientists would decide, today let's try this transector, let's explore this part of the seamount.
The robot would swim over sands and sand and rocks, and then every once in a while it would come across these amazing biological congregations. So one thing we saw was one of the first ever photographed giant crab migrations.
People have not seen those crabs in those areas with that large aggregation ever before.
The robot swam over it, and of course, because it can't adaptively respond to what it's seeing in any way, it's just doing a pre-programmed trajectory, it swam right past it and then continued to look at rocks and sand for the rest of the 2-hour mission.
But what if robots could be trained to spot the unusual? What if robots became curious?
If we had the curious robot in that context, we would have had much better data.
That's Yogi's goal, to train robots to be curious, so that next time they see something unexpected, they'll follow it. At his lab in Woods Hole, Yogi and his team are testing their programming in an off-the-shelf submersible robot.
Yeah, I can see that.
Do you want to pilot?
Oh, no, go ahead.
The first step is simply introducing the robot to its environment.
The way that we define curiosity for the robot is it's the most curious about the thing that it can explain the least well.
What we have the robot doing right now might be more like a really excited puppy or a small child going out into the world, and it's absolute pure curiosity in its most naive sense. It's just excited to see whatever the new thing is. And whatever that new thing is, it's going to go towards it until it gets bored, and then it's going to leave and go somewhere else.
Blackbeard is the hardest thing to explain. It's got, it's kind of crazy looking, and therefore the robot's the most interesting to Blackbeard.
Curiosity comes naturally to human beings, but to put it into a robot, the team had to learn to think like a robot.
Our robots go into the water like fresh babies into the world. Baby doesn't know anything, it can extract color, it can extract texture, and then it starts to kind of cluster and realize that, these colors that all go together maybe form an object that's my mom, and these colors form an object that's my dad, and that's what the robot is also doing.
The goal is to have it do something intelligent even when there is a blank slate.
Scientists don't know what these robots will find, so they have to be able to decide what's interesting even if they can't identify it. The robots do this by sorting what they see.
And then it sees this carabiner, and the carabiner looks very different than any of the blocks. And relative to how different the blocks are from the carabiner, these blocks actually look pretty similar. So maybe the robot, we'll put those into one category.
By grouping objects into categories, the robots can pinpoint the unusual.
And at this point, the robot is really sick of blocks. I think we're all really sick of blocks. And then it sees this man for the first time, which is really interesting to the robot. It's never seen anything like this, and so it gives it a new category. So at the end of the mission, the robot has a block category, which it doesn't find very interesting, a carabiner category, which is relatively interesting, and then these two very different categories, which it's the most interested in. The robot knows nothing, and therefore it can learn anything.
Teaching one robot to be curious is a great start. But if scientists want to explore the entire ocean, they're going to need a whole team of curious robots. And like us, each of these robots is going to learn a little differently.
One robot might say, this is something with a whole bunch of red and a little bit of blue, so it might maybe by color. But another robot might see all this texture and say, Blackbeard is just a really, has a lot of sharp edges, right? So what we want actually is for these robots to talk to one another and then ultimately agree on what category does Blackbeard fit in? What is the descriptor for a Blackbeard category?
But even if the robots can agree on categories, they're still going to see different things.
When one robot sees something and it becomes boring for that robot, we'd like it to be boring for all of the robots. Essentially what we're trying to do is have all of the robots bring their prior experience to the table.
At the end of this, kind of the things that our robot will be curious about are essentially this blue block and this Lego man, which are the things that fit the least well into the models that are described by the data that we've seen so far. We can actually send that information to the other robots in our team, and so that's what we'll do.
The robot has received new information from one of its robotic teammates that objects that are shaped like this and red and pointy are not as interesting. The other robot teammate has seen a lot of them. And so in light of this new information, the robot can actually decide that this is not as interesting of an object. And what's left is that this Lego man emerges as the thing that the robot is the most curious about that it's seen so far. After receiving the information from Robot Kevin about what he has seen about the world, I will in turn send a message about my representation of the world. So my knowledge of the world is that there are lots of blocks, quite a few carabiners, and a lot less little Lego men and screwdrivers.
Okay, so our robot teammate has actually just said that they've seen a lot of Lego blocks and not that many of these Lego men. So what we know now is actually that these blocks are not nearly as interesting as we thought they were across our entire team. But these Lego men are actually the most interesting thing, and we should seek out new observations of these.
Right now, the team is focusing on teaching their robots how to create a worldview they can all share. But that's not their ultimate goal. What they really want are robots clever enough to be not just tools, but partners.
We want to have these robots explore like a scientist would.
Even though the scientist can't go down with the robot, we want it to be able to, the scientist to be able to send kind of the way that they would behave underwater along with the robot.
We want the robot to grow up, really, to go from being sort of this purely curious child into a more mature robot scientist.